Hello, Mr. Darling. This is my video over 1.1 in the unit for my choice activity, and I'm going to be going over vocab. So firstly, we review the atom, which is the smallest piece of an element that still remains the properties of the element. Now, we're going to go over atomic mass number, which is the total number of protons and neutrons in a nucleus. We know how atomic number, the number of protons, just the number of protons. Atomic mass unit is the average mass of the atoms in an element. Density, mass per unit volume of a substance. Electron, subatomic particles with a negative charge that's in the outermost that are in the electron shells. Element, substance with atoms that are all pure, all alike. Group, column in the periodic table. Ion, a charged particle, could be negative or positive. An isotope, an atom, has a different number of neutrons. Metal is an element that is shiny, malleable, ductile, and a good conductor of heat and electricity. A metalloid has some properties of metal and some properties of non-metal. Non-metal is an element that is usually gas. It's brittle most of the time. It's a solid at room temperature. Solid at room temperature is not malleable or ductile. Is a poor conductor of heat or electricity and typically not shiny. The neutron is a neutral, no charge. It's in the nucleus. Nucleus is the small, positively charged center of an atom because it holds protons and neutrons. The octet rule states that every atom wants at least a full outermost valence shell of 8 electrons. Period is the horizontal row on the periodic table, and a proton is a particle in the nucleus with a +1 charge. Alright, now we're going to be going over Now, I'm going to go over models. So, the first model is the Bohr model. It's the correct location of all the protons, neutrons, and electrons in the actual atom itself. So, it's going to be a circle with more rings. You're going to need 4 shells. There's going to be 2, 8, 18, and 32 in those. And everybody wants at least a full one in the 8. Then we have the Lewis dot structure. It shows only the number of valence electrons in the outermost shell. Sorry. Let me get back to this paper real quick, because I'm going to be done with this unit. Alright, so ions. An atom that can atoms gain or lose electrons to be ions. If it loses an electron, it's going to be a positive ion. If it loses a proton, it's going to be a negative ion. Neutral atoms have the same amount of protons and electrons. An ion does not have the same amount of protons and neutrons. A cation is a positive ion. So the cation had to lose an electron. So it's most likely a metal. An anion is a negative ion. So it has lost a proton to gain a negative charge to fill its most outer shell. And denoting the charge of an ion, a positive ion is with just a plus sign, and a negative ion is with the minus sign. And so, isotope. So, isotopes is the change of a number of neutrons. So usually, you gain neutrons in an isotope much rather than lose them. So, some popular examples is carbon-12 and carbon-13. They're radioactive isotopes. That's it for my video.